Hello everyone, today we are going to finally learn something new. So we are going to talk about sequences, series, and sigma notation. And you've worked with different sequences before, I believe in Algebra 1 Volume 1 class. I don't think we've done much about sequences in Algebra 2 class, so this is going to be a good review and also a start of something very, very fascinating. So first of all, sequence, it is a function with a domain that is a set of natural numbers. Well, natural numbers, think about what are the natural numbers, right? Definitely not negatives. And then those are the nice numbers. The next definition that we need to know, that what is a term of a sequence. So I said that the terms of a sequence are the range of elements of a function that are a set of numbers. We will talk about two types of sequences. The first one is the finite sequence. It is going to have a fixed number of terms. So for example, if I say I have a sequence that is 1, 2, 3, 4, 5, that's it. That's a finite sequence. It has a fixed number of terms and that's it. But then I could also have an infinite number of infinite sequence that will have infinitely many numbers of terms. Well, if I say 1, 2, 3, 4, 5, and so on, let's say that this pattern continues, that would be the infinite sequence. All right, we'll have two types of formulas that we are going to use for our sequences. The first one is going to be called an explicit formula. And explicit formula defines each term in a sequence directly without knowing the value of the previous term. So if you think of the first example, I have this term, this term, this term, this term. I can look for the pattern and you can tell me what are the next four terms of the sequence. You can do this by yourself. Then the same thing with this one. You can do this by yourself. But now let's take a look at the next question. And this one, what I want to do is I want to find the first four terms of a sequence given with the formula that is like this. So I want you to see what is happening here. An is defined as n to the power of 3 minus 10. The first term is going to be, I am going to replace the n with 1. 1 to the power of 3 minus 10 is equal to negative 9. The second term, I have, I will plug in 2 in place of n. So 2 to the power of 3 minus 10 is going to give me negative 2. And so on. In place of n, I am plugging in whatever term I am looking for. So I do not need to know the previous term in order to find the next one. And here is my answer. I found the first four terms of our sequence. All right, so on this page, we will do A and B. Those should be pretty straightforward. All right, if you go on the second page talks about the recursive formula. And the recursive formula defines each term of a sequence using a previous term. So if we take a look at example number 2, we have a nice formula that the nth term is defined as n minus 1 term. So for example, if I say that nth term is fifth term, the n minus 1 term would be fourth term, which means previous term. So let's take a look at the way I solve this. The first term is 1. So then the second term, I take my previous term, which is 1. That's the 1. And then I plug it into the formula. So plus 2 times n, and n is 2 because it's the second term, minus 1. Make sure you follow the order of operation. The answer is 4. If you go to find the third term, you will use the previous term, which is the A2, which we found right in here, plus 2 times 3, because we are plugging in whatever the n is, minus 1, again, order of operation. And by finding the next term, you will finally get to the fifth term, and here's our answer. what I want you to do is I want you to try the B. That is going to be one of your assignments. And that is going to bring us to the Fibonacci sequence. I will assign a video that will go with this lesson as well, that will talk more about Fibonacci sequence. But Fibonacci sequence, it's a beautiful sequence where you take 1 and 1, those are your starting numbers, and then the next term is the sum of the two previous ones. This one is the sum of those two. This one is the sum of those two. This one, and so on. Fibonacci sequence you can see in nature in many different places, but again I will put the link to the video that I want you to watch on your assignment. I want everyone to try example 3. As I said, it has to do with the Fibonacci sequence, so look for the pattern that happens with the Fibonacci sequence. All right, read the question very carefully and you should be able to figure it out. All right, if we go to the next page, I talk about the sequence. The sequence may either converge or diverge, and as a function, an infinite sequence may have a limit. You will see, we'll learn all about limits soon, not today, but soon within the next few lessons towards the end of this unit. And if a sequence has the limit such that the terms approach a unique number, then it's set to converge, and if not, it's set to diverge. I will show you 2 of the examples. So if I have a sequence that is defined that the nth term is negative 3n plus 2, let's see, that would mean that the first term is negative 3 times, in place of n, I am going to plug in 1. Negative 3 plus 12. And negative 3 plus 12, that is equivalent to 9. Second term, negative 3 times 2, again in place of n, I am plugging in this number. So negative 6 plus 12 is 6. Third term is going to be negative 3 times 3 plus 12. So negative 9 plus 12 is equal to 3. And we see that this pattern is going to continue. If you are not positive, let's do one more. The fourth term would be negative 3 times 4 plus 12. Negative 12 plus 12 is 0. And look at this, 9, 6, 3, 0. I am assuming that the next number is going to be negative 3, negative 6, and so on. So it's going to go towards negative infinity. So if you look at the second example, I want you to see the difference first. The first term is 36. The second term, if I follow the formula, it is negative 1/2 times the previous term. And the previous term was 36. So negative 18. Next term is going to be negative 1/2 of the previous term. Next term is going to be negative 1/2 times previous term. Next term is going to be negative 1/2 times previous term. And so on. Well, I want to make sure I know what this means, and if I am not sure what to do or what does this mean, I draw a picture. So for my first term, I am at 36. For the second term, I am at negative 18. For the third term, I am at 9. For the fourth term, I am at negative 4.5. Fifth term, and you can see how this pattern continues, and you see how our limit, it appears to be 0. So because of that, my first example is going to, well, let's see, converge means that if a sequence has a limit such that, so it looks like this one will converge, it's going to be convergent. And this one is going to be divergent. Okay. All right, let's take a look at the series. There's a lot of new information on this paper. If we look at the series, what happens is a series is the sum of all the terms in a sequence. So far we were talking about the sequences. Now if I take the terms of the sequences and add them, that is going to give me a series. With the series, I can have two kinds of series. I can have a finite series and infinite series. Finite, it will be sum of all the terms in a finite sequence, and infinite, it's going to be a sum of all the terms in the infinite sequence. So let's see. If I have a sequence, that would be, for example, 1, 2, 3, 4, and I'm going to end it right there. If I have a series, it would be a sum of all those terms. Done. Now this one, let's say I have 1, 2, 3, 4, and I say that this doesn't end. Series, and this one doesn't end. All right, we'll see what happens with those later on. There's a lot of information in this unit. All right, there's something that is called an nth partial sum, and it is a sum of the first n terms of a sequence. Well, let's see what it means. If I want to find the fourth partial sum of a n, defined as -2 to the power of n plus 3, what I am going to do is I am going to plug in for n first 1, next 2, then 3, and then 4, and then I am going to figure out what the number is. So again, because it's fourth partial sum, what I need to do is I need to find the first term. So that's -2 plus 3, that's 1. The second term is -2 to the power of 2 plus 3. That is going to be 4 plus 3, that's 7. A3. That's -8 plus 3. -8 plus 3 is -5. And A4. -2 to the power of 4, that is 16. 16 plus 3 is 19. And if I want to figure out what is the partial fourth sum, that is like, if you think about this, it's a sum of the first fourth term, and that is going to be 1 plus 7 plus -5 plus 19. And that is going to be equivalent of 22, if I didn't make any mistake right there. All right, and here's one for you. Make sure you find your A1, make sure you find your A2, and make sure you find your A3. Once you have those three terms, add them together, and you will be able to figure out what the answer is. Will an infinite series have a sum? Well, it will, sometimes. If it converges to 0, then it will. But again, that is something that we are going to be exploring later on. All right, the last thing that I do want to talk about very quickly is the sigma notation. And if we look at this one, I think it's just the best to look at the example, but n is the index of sum, k is the upper bound, and 1 is the lower bound of this. So what we are doing is we are starting from the first term, and we are going to the whatever the term is defined by the top number, and then we are going to add all those terms in between. So if we quickly look at one example, how to figure out the sum. This is my formula. And what I need to do is I need to plug this in. So I am starting with n is equal to 1, so 4 times 1 minus 3. But I have to do this for n is equal to 1, n is equal to 2, n is equal to 3, and n is equal to 5. And then this sign tells me that I need to add them all together. So this is my first one. Then the second one is 4 times 2 minus 3. Then the next one is 4 times 3 minus 3. And the next one is 4 times 4 minus 3. And the next one is 4 times 5 minus 3. If you do this all out, you will get 45. Have fun with B and have fun with C.